Hello, Sevens, and good morning again. So for those people who are ready, if you're here watching this video, you should have already checked in with me about the surface area and volume assignment of cylinders. And you should already have, you might only have I don't know, 80 or 90% done, but you've done the vast majority of that assignment. You've submitted things, you're good, and you're ready for this investigation. And I hope it's interesting. So in this investigation, and feel free to use calculators, first of all, because we'll deal with pi a bunch and it just will make calculations so much easier. And round answers to the nearest hundredth of a yard. In case you don't know, a yard is 3 feet. It's really similar to a meter. I always forget which one is a little bit bigger. I think a yard is slightly bigger than a meter, but they're very, very close. So 4 yards by 6 yards is really close to 4 meters by 6 meters. And then we've got a goat with a rope tied to the corner here. So then the dimensions of the shed are given, and what I'm going to play with as I go through these is the length of the rope. So this one, the rope is 3 yards long, you'll do some things. Here the rope is 4 yards long, you'll do some things. Then the rope will be 6 yards long and then 8 yards long, and I ask you to do some things. Great. I also have some follow-up questions. So instead of starting with how long the rope is, here I'm starting you with the amount of area that the goat can reach. And so it just kind of flips the problem around the other direction. So that said, I want you to go ahead and think about this scenario and sketch what it would look like if the rope were 3 yards long. Go ahead and sketch it in this space, pause the video, sketch it, and then play the video again, and I'll show you what I get. So welcome back. I assume you have already sketched that, and now I have my tools up so I can show you what I got as well. When I sketch this, I would have, of course, our 4x6 shed. This is 4x6, and the rope is 3 meters long. It should be longer, because if this is 4, then 3 should be like somewhat close. So, and then this is a rope, meaning that could go all the way around here. It could go, come on, all the way here, making a circle-ish. Wait, that side is 6, so this 3 is way too big. Sorry, let me just do, no, I can't. Just to clean up the dimensions of things. So here we've got shed. If this is 6, 3 should be half of that 6. So I'm thinking 3 being something like that. That's more realistic. And then we want to find the area about this circle. Well, you know how big the circle is, and you can see what portion of the circle this is. I think you can find that area, go for it. But before you go to areas, I want you to go and sketch what happens if the rope is 4 yards long, if it's 6 yards long, and if it's 8 yards long. Pause the video now and sketch those next 3, and then I want to show you the way that it would look for me. Okay, I'm assuming you already paused the video and you sketched what it looks like if the rope is 4 yards long, 5 yards long, 6 yards long, blah, blah, blah. So let's go ahead and, come on, give me the erase everything. So, okay, if the rope is 4 yards long, we've got, again, this is 4x6. Now our rope is 4 yards long, which is this length, which matches that. So I should have this circle that goes all the way around, come on. And that is a really bad circle, but you can see the radius of that circle is 4, and it is circular-ish with a center right there. Good, then you can go ahead and find that area. Now that you see at 4 yards, that rope hits the edge of the shed right here, which means something fundamental will change when we get to 6 yards. So let's go look at the 6 and 8 yards. 6 yards. Same type of idea, but this is 4x6, and now this is a 6 yard long rope. Maybe I'll try to use a different color in this case. So rope is 6 yards long, which is like that. So I'll have this semicircle going, semicircle there, but I can keep it going. We end up going, if the rope goes straight out that way, it can reach 6 yards, which is further than the 4, which means we end up with this second little area here, where the radius there is 2, and then the radius here is 6, and we'd have to add together this chunk of this circle with this chunk of the little circle to get that. And so if the rope is 8 yards long, we end up with similar things. I'll go ahead and sketch it. We have 4 by 6. So if our rope is 8 yards long, come on, there we go. The rope is 8 yards long, that's 6, 8 yards goes all the way out there. So if this is 8 yards long, we end up with this circle. That's not very circular. Should be bigger than I'm saying. This is 4, so this will be 4. And this is 6, so this will be 2. The radii of the circles will respectively be 8, 4, and 2. And then from there we can add up these areas and get an idea for what that looks like. The extra, like the challenge questions, are going to be these questions. What length of rope would allow the goat to reach exactly 25 square yards of grass? That's actually a pretty difficult question. This one up here, I think you'll be all right with 10 square yards, but it's because we have this fundamental change thing that happens when the rope gets to a certain length. It makes this question significantly more difficult. So those are the things I want you to attack and go for. Find the area of each section, submit your stuff at the end of the hour, and thanks a lot. Have a great day, Sevens.